Using Sohcahtoa to find a missing side length in a right triangle. So I got a couple of right triangles sitting up here, but let's see. I always like to start when I'm dealing with right triangles to write Sohcahtoa at the top of my page. Okay. Well, I got a right triangle here, and I'm going to locate my hypotenuse, and when I do, I find that it is what I'm actually solving for, which is x. Then I've got theta up here, 53 degrees, and the side opposite it is 15. Opposite over hypotenuse. So I can use the sine function to find the measure of the hypotenuse. So let's set this up. So the sine of 53 degrees is equal to the opposite side, which is 15, over the hypotenuse, which we're labeling as x. Well, let's multiply both sides of this equation by x, and then we got x equals the sine of 53 equals 15. And then why don't we just divide by the sine of 53 both sides to isolate the x, and so the x is going to equal 15 over the sine of 53. Now we're going to finish calculating that on the calculator here in a moment, but let's go ahead and deal with this other triangle. All right, I got a right triangle here. I'll locate my hypotenuse, but it doesn't appear that it's going to enter into my equation. And here I got theta, which is 21, and the side opposite it is 9, but it's the adjacent side of theta, or 21 degrees, that I don't know. Opposite, adjacent, oh, sounds like a tangent. So I see the tangent of 21 is then going to equal 9, which is the opposite, over the adjacent side. And once again, we're going to multiply by x both sides. Now we got x equals the tangent of 21 equals 9. But to isolate the x, we got 9 over the tangent of 21. Now let's go to the calculator and let's calculate 15 over the sine of 53, and which is the hypotenuse of our first triangle, and 9 over the tangent of 21, which is the adjacent side of our second triangle. What do you say? What do you say? What do you say? All right, are you ready? Are you ready? All right, let's see. The first one we had was to find the hypotenuse was 15 over the sine of 53. So we got 11. We've got 15 divided by, man, I'm double hitting everything here. So we want the sine of 53. 15 divided by the sine of 53, that acute angle 53. Let's hit enter and see what that missing side length, which is the hypotenuse, is. And we're going to round it to the nearest tenth. Let's see what kind of mode I'm in here. Critical mistake. I need to be in degree mode, not radian mode. I should check my mode first. Let's get this thing over here in degree mode. Now, let's go back and redo this. That's a good object lesson. Didn't mean to do that, but hey. So 15 divided by the sine, hitting the sine button, 53. Close my parentheses. Round into the nearest tenth. That's better. 18.8. Don't know what the unit of measurement is, but hey, we're going with it no matter what. All right, let's see. Our next one, we were trying to find the adjacent side, where we had an acute angle of 21 and an opposite side of 9. So we're going to use our tangent function. And this time it's 9 divided by the tangent of 21 to find that adjacent side measure. We're going to round it to the nearest tenth. And it is 23.4. Shazam!